Hi, today I'm excited to introduce you to Oracle, the first practical and secure federal learning platform that reimagines how we handle data privacy and model training and trust in AI. So the vision behind Aura was to make a near practical implementation of federal learning, and we did this with help of Mina and ProtoKit. So we basically made zero knowledge circuits in their language in OpenJS and have verified inference of models from local clients on the local data. Now more of this later on when I explain you our architecture. So I will click on get started and you will be met with a dashboard. Now you can be two types of people in OraFL. You can either be a publisher who publishes his model for trainers to train. So trainer train their model on local data, and that's what I'm going to show you. So here is a new model. I will name it my good model, and you have three type of model data, that is CNN, RNN, and LSTM, activation function of ReLU, Adam optimizer, and a number of layers of one. And because the computation of zero knowledge proofs is heavy, I'm going to very much restrict for the sake of the demo. Now I will click on number of epochs, let's say 4, and fee per epoch is 20. So I will publish this model. My wallet opens, so I will type in my password to unlock it, and I will sign the transaction, and we should see transaction sent and transaction was added successfully. Now I will reload, and while that happens I will log in as a trainer on another this. Now this is a new account, so I will first show you that I have to connect my wallet. I will connect, I click on get started. Now I want to be a trainer. So if you want to be a trainer, you have to stake some Mina in the network or the local native token of Mina. Now as I do not have nothing, I have made a endpoint for faucet. As the balances module does not have some L1 interaction, a limitation of ProtoKit right now, so I have made a faucet endpoint for getting the L2 Mina-net tokens. I will click on sign, and hash a transaction was sent and transaction was received, so I can have 1,000 Mina now. Now I will stake, I will sign, the stake was sent, and we will wait, the stake is available. So I get loaded all the possible models that I can train. Let's say I accept this, my good model, and I'll accept this on accept, and I have successfully accepted the training, and I will click reload. Now I will basically see if I can accept also here. So I will go and trainer. So I will basically show you two clients. One is the publisher itself, so it's a little rudimentary, but with the limitation of browsers I will go do this and I will see. So yeah, so let it load. I will go on this and I will see if my model comes here. So yeah, so what I can do is I can locally train this model. Now how did I do this is I did this in the browser itself, because in real life practical setting what would happen is that you would use the browser itself for training the model. So I will click on train. Now this generates a random TensorFlow one layer model, and with some kernel, some bias, and some input. Now it also verifies your inference. There is a zero knowledge proof of circuit that verifies your inference, and we will shortly see the compiled model version here, the verification key for the compiled model. Now I will do the same for another this, what we say, another trainer. So I will click on training and I'll train. I'll also inspect it here, and I will also, a verification key was generated, and I'll wait. So I'll have to speed up this part a little, so I'll speed this up as to keep my demo below 4 minutes. And so right now a proof is being generated. I will show you the code. So first I will show you how this works. So go on the console. So basically we downloaded a proof.json. I sign, and I will basically show you the proof.json that I trained. I also sign this transaction that verifies my inference. Now I will the proof.json. Wait, let me open this proof.json. So this opens. So this is the zero knowledge proof of knowledge that is generated, and you can see the same happened for here. Proof4.json was generated. Okay, so what is our architecture? Our architecture looks something like this. A publisher basically comes and he publishes some model C1. This is the desired architecture. He publishes to let's say n trainers. The n trainer then aggregates the proof and this generates. So what we do is we have a publisher. We have a module runtime on the protokit that manages all the tasks. It sends all the tasks to the trainers. It fetches the trainer fetch all the available tasks, assign themselves a task. If the trainer wants to first participate in the network, they have to stake. Then the trainer train with help of TensorFlow.js. This happens locally to emulate local data. I have a random tensor in place. The TensorFlow.js computes the proofs and the params, send it to an aggregator endpoint. Aggregator endpoint, what it does at the runtime, verifies the proof, and the aggregator endpoint aggregates the model. Now the aggregator endpoint is, I will show you. I will now come as publisher and I will mark my model complete. It again helps me to sign a transaction, and a param.json file is generated. It's the weights and biases, and the publisher.complete task was successful. So, and my balance was gained by 4 into 5, whatever, it was the half of what I started. And so now what I will do is this aggregating endpoint then generates a crumb proof if the bad actors were in place, and it goes into the slashing endpoint of the shaking runtime, and the slashing endpoint then manages the slashing of the stake for bad actors. So what I will do is I will show you the code or the circuits now. So what does a circuit look like in a language like protokit? So it was basically an OpenJS circuit. So a crumb function is very famous in Byzantine fault tolerance, and what happens is it maintains fairness by calculating that whether a client was too far away from the threshold of the model parameters of what it should have been. So it basically calculates some sort of delta between the threshold and the the model params that came back from the client, and it then punishes the bad actors by removing their stake. The aggregator basically verifies a head layer proof. A head layer proof is very simple program right now. Now what I wanted to do was make a intensive head layer, and to basically model this inference afterwards to basically scale up this inference. I took inspiration from a 512 recursive zk-SNARK circuit, and because that was too heavy for basically OpenJS to compile, it took too much long, and my laptop did not have enough memory. So that is something I could not have done. So I made a very simplified version of the program, and that is used to verify the inference. Now this is only the head layer inference because I have only a layer 1 model. For an n layer model, we have to scale up this, and we have to basically, for each layer we have to do inference separately, and then what we'll do is we will basically verify each layer's inference, so no tampering happens in between and everything is maintained proofly. So that has been ORAFL. Thank you guys.